So our first speaker today is Dr. Nathan Fox. Dr. Fox is a distinguished university professor of human development and quantitative methodology at the University of Maryland. He also directs the Child Development Lab there. So Dr. Fox conducts research on the neuroscience of human development and the biological basis of social and emotional behavior. He received a Merit Award from the National Institutes of Health for his work on the precursors to anxiety. He's co-leading a number of large studies, and I will mention just two. In Romania, he's examining the effects of removing children from institutional care and placing them in high-quality foster care. Through this longitudinal study, the research team is monitoring the effects of early deprivation and looking at the impact of an early intervention, foster care, on children's cognitive function, physical growth, and emotional development. He also is studying the mirror neuron system of infants and young children to better understand the interrelated deficits that characterize autism. Finally, Dr. Fox is a founding member of the National Scientific Council for the Developing Child and currently serves as its co-scientific director. And today he will discuss the impact of early experiences on brain and behavioral development.
Morning, everyone. First, let me thank Heidi for inviting me. I came out of the bullpen when Sarah Watamura could not come back. I understand she was here on one of the coldest days that you've had here in Madison in a while, but I appreciate the invitation. Heidi asked me to give you a little bit of background about myself and how I came to study this, and so I thought I would spend just a couple of minutes doing that. About 25 years ago, there was a meeting at the White House on early childhood, and after that meeting, there was a lot of public interest in the effects of early experience in the first years of life. Newsweek had a picture of a baby and said that all of these neurons were developing and the brain was developing in the first year, and if things didn't happen very soon, then it was all over. Well, the MacArthur Foundation at that time organized a working group called Early Experience in Brain Development, and I was invited to be part of it. And it was a group of neuroscientists and developmental psychologists who were asked to come together to explore exactly what we did and did not know about early brain development and the effects of early experience. That working group transformed after about 5 or 6 years into a group called the National Scientific Council for the Developing Child. And that too is a group of neuroscientists and developmental psychologists who are interested in being able to identify what are the science backgrounds for understanding early brain development and translating that information for policymakers like yourself. And there were two things that National Scientific Council did from the outset. The first is it partnered with the National Council for State Legislatures, and you'll hear from Megan later about that group. And so it decided to work with state legislatures as opposed to working at the federal level. And the second is what we did is we partnered with a group called Frameworks, which was a group of individuals who were actually cultural anthropologists and linguists, but who understood that we as academics could blather on for quite some time and had a hard time in transmitting information to policy makers in a cogent and focused way. And so my talk this morning is a brief review of what we know about the science of early brain development and hopefully with a number of messages that have been translated and are understandable to all of you. Okay, so let's start with 3 core concepts for development. The first is that brain architecture is established early in life and supports lifelong learning, behavior, and health. Now, I'm going to point out for you where the metaphors that we developed with frameworks, where they fit in to my talk. So the first is, well, how are you going to talk about brain development? Well, they said, well, it's sort of like building a house. And you have to understand that there's a foundation, there's wiring that takes place over the first months and years of life. And so there's an architecture, there's an architectural plan, and that architectural plan is influenced by experience. Over the course of time, you may say, well, you know, I don't like the way the kitchen looks. I want it moved over here, or I want the wiring to be over there. And so your experience influences the way the architect designs a house. In the same way, early experiences influence the way the brain is wired. The second core concept is that stable, caring relationships and what we call serve and return interaction shape brain architecture, and I'll say a little bit more about that in a second. But again, that second metaphor, serve and return, and I'll come back to that in a moment. And the third is that toxic stress, and yes, we were the ones who coined that term so many years ago, in early years of life can derail healthy development. So let's start with early experiences, build brain architecture. What we know is that brain architecture and the development of that wiring of the brain supports lifelong behavior, health, and learning. Brains are built over time, starting at the earliest months of life. Simple skills beget other skills, more complex skills are built on top of them. And cognitive, emotional, social capabilities are all intertwined together, starting from birth. A strong foundation in the early years improves the odds for positive outcomes. And like anything else, if you're building a house, a weak foundation increases the odds of later difficulties. Here's one of my, as I get older, one of my favorite PowerPoint slides. This is the plasticity of the brain. And I'm sort of over there on the left-hand side. But you can see that normal brain plasticity is greatest at birth and in the first years of life, and decreases. It doesn't decrease to zero. There's still a bit of plasticity, and we can still continue to learn. But what's also important is that the physiological effort that the brain needs in order to enhance neural connections becomes greater as we get older. So it's harder for me to learn a new language than it is for a young child. And so there's a sweet spot where that crosses somewhere around midlife, where before that, you really have the best chances for plasticity and effort coming together. Now, what we know from the neuroscience is that the brain develops in different rates, at different rates, in different parts. So the parts of the brain that wire up first are in the sensory areas, vision and hearing. The parts that wire up next are associated with language, and the parts that are associated with greater cognitive abilities, they take a longer period of time to develop. See that clearly there. And in the first year of life, that's a critical period of time, you have the emergence of the sensory areas and the greatest period of time for the wiring of language development. Here's a good illustration of how brain development occurs over the first years of life. This is a slice, if you will, of neurons. Those are neurons, and the long things there, those are axons. And you can see that at birth, in this slice of the cortex, that's the front, the covering of the brain, they're pretty sparse. But now look at that at age 6 years, okay? So there's been a dramatic increase in the connections and in the number of neurons and connections in the brain that is occurring over those first 5 years of life. By age 14, adolescence, what you see is that many of those connections have disappeared. Neuroscientists like to think of themselves as gardeners. And so they talk about the blooming of synapses that occur in the first years of life and the pruning of synapses that occur afterwards. But the example, the metaphor that I like to use for that is training wheels. What the brain needs in the early years of life, and teach a child to ride a bike, you give them training wheels first. So there are supports for learning that occur, and that's where all of these connections are used in the early years of life. But as learning is solidified, as you learn to ride that bike, you can take the training wheels off, and that's what the pruning of those neurons allows you to do. Okay, the other important point that I'd like to make about brain development is that there is a concept that neuroscientists call sensitive periods. That is that there are limited periods of time during which the effects of experience on the brain are particularly strong. And that allows experience to instruct the brain, the neural circuits, to process information in an adaptive way and to provide information that is essential for normal development. Now, this illustration, I think, nicely shows that. You can see here that those are the same sort of changes that I showed you earlier in terms of sensory, motor, and cognitive development. But what happens over the course of early experience is that there are periods of time when experience exerts a particularly dramatic and powerful effect on brain development. Before neuroscientists, there was an ethologist by the name of Konrad Lorenz who talked about what he called imprinting. And some of you may remember from your Psychology 101 textbooks that there's a picture of Lorenz with the baby ducklings because he showed that if the baby duckling sees something moving when it's hatched, it'll follow it. So Konrad Lorenz called it imprinting. But it wasn't until two neuroscientists by the name of Hubel and Weisel did experiments in the 60s in which they showed the effects of early experience on the brain. There you see what they did is they first worked with kittens and then with non-human primates, and they showed that restricting visual experience in the early months of life led to deficits in the areas of the brain that had to develop as a function of early visual experience. And it wasn't only the deficit or a lack of visual experience, but it was the timing in which that deficit occurred. It was the timing in which that experience was not allowed to have its effect on the brain. There's a developmental psychologist by the name of Daphne Maurer who actually translated that to human development. At the time when she started her work, she noticed that there were infants that were born with bilateral cataracts. So they did not see clearly. And the age at which they got the surgery to remove those bilateral cataracts varied. And she found that, in fact, the infants that received the surgery early in life, they saw fine. But the infants that had the surgery later in the first year of life, they, in fact, had deficits in visual acuity. We also know from work by developmental psychologists that there's critical periods in terms of language development, in terms of hearing different languages, and in terms of being able to detect different languages. Before 9 or 10 months of age, infants around the world can detect differences in consonant and vowels across all the languages in the world. But starting at around 9, 10 months of age, after they have heard their own native language, they can no longer do that. So there's a sensitive period during which the input, the language input, has its greatest effect. Okay, now on to the second core principle, which is interaction shapes brain circuitry. When we thought about a metaphor for this, we came up with a metaphor of serve and return. So for those of you who play tennis, it'll immediately come to a mind in terms of volleying, right? So you hit the ball and your tennis partner hits it back to you, right? It's the same thing when you think about interaction between an infant and caregivers. Young children naturally reach out for interaction through babbling, facial expressions, and gestures, and adults respond in kind. These serve and return, going back and forth, the dance, if you will, between an infant and its caregiver and its mom. These interactions are essential for healthy brain development. And so, given that, the systems that support the quality of relationships in early care settings, communities, and in homes also support the development of healthy brain architecture. Here's an example from some scientific data about that. There was a study that looked at the input that infants from different homes had in terms of vocabulary development over the first 3 years of life. And you can see there's just a clear difference in terms of the socioeconomic status or education of the families and the child's cumulative vocabulary. And that's due to, researchers have found, to the amount of language, to the number of words and amount of language that a child hears in their home environment. The other principle associated with serve and return is about what we call, again, another metaphor, called the air traffic control system. I think it's important to mention that executive functions are a group of skills that help children adapt and regulate their behavior. And it is, in fact, these executive skills are a key foundation for school readiness as well as for health and employability. So what are executive skills? I don't have time to go into them in detail, but let me just name 3. Inhibitory control, that is the ability to inhibit an impulse. You may, I don't know if you see that picture there, but you may have heard about the marshmallow test, right? Being able to inhibit a response for a period of time. Working memory, the ability to hold and manipulate information in our heads over short periods of time. And cognitive flexibility, which is the ability to adjust our behavior to the changing demands and priorities of a particular situation. But what do we know about these skills? Well, we know that higher childhood self-control predicts better adult health. You can see that here, both in terms of better adult health and in substance use dependence. We also know that higher childhood self-control predicts less adult crime. Okay, the third core principle is that toxic stress derails healthy development. So when we thought about how to understand and communicate the idea about stress, we all experience stress in our daily lives, in our workplace. And in fact, stress is, and sometimes good for us. And so when we came up with this metaphor, we decided to present 3 different levels of stress. Positive stress, which increases heart rate, mild elevations of stress hormones. Tolerable stress, which is serious temporary stress that is buffered by supportive relationships. But finally, toxic stress, which is prolonged activation of stress response systems in the absence of protective relationships. And I do want to emphasize that that's an important point. It's not only that the child or the individual is stressed, but that they do not have the supportive relationships or the social networks that can help them buffer and cope with the particular types of stress that they're undergoing. So, learning how to cope with moderate, short-lived stress can build healthy systems, but toxic stress is when the body's stress response system is activated excessively, and it can weaken brain architecture. And to my point, without caring adults to buffer children, toxic stress associated with extreme poverty, neglect, abuse, or severe maternal depression can have long-term consequences for learning behavior and physical and mental development. In fact, we know that from the neuroscience. You can see differences there. That's a normal neuron with all of the dendrites, and you can see there the same area of the brain, but the neuron when it has undergone toxic stress. And what you can see there is the lack of all of the dendrites, the connection branches that have gone away as a function of that stress. And you can see there's an electron microscope which shows you neurons damaged by toxic stress and lack of connection. Now, what do we know about early stress? Well, I'm sure many of you have heard about the Adverse Childhood Experiences Study, 1997. Kaiser Permanente did this survey in which they asked people about their childhood experiences, about abuse, neglect, and household challenges. And they found that the cumulative number of these experiences was related to adult health and disease. Here's just one example. The number of ACEs, which is along the x-axis there, is related to the risk for and presence of adult cardiovascular disease. And I want to make this point, which is that toxic stress is not only bad for brain architecture, but it has long-term consequences for health and for the development of significant diseases, which cost us as a society a great amount of dollars because of the health care that's necessary to take care of people with these diseases. The other point is that neglect in our child welfare system is in fact the most common form of child maltreatment. And we know that neglect is bad for the brain, and that's because the brain expects input that it doesn't receive, the wiring is perturbed, and particularly egregious if these experiences occur during what I talked to you about earlier, which is sensitive periods, when the child is expecting to hear language, when the child is expecting to see different types of stimulation, when the child is expecting to be engaged in serve and return. Here's an illustration from research that I have been doing with my colleagues in Romania. And what you could see here is the difference between the brains of two sets of children. Those who come from typical households where they are raised in families, and those who are raised in extreme neglect. And the red in that map is active brain functioning, and you can see the absence of that in the child who is raised in neglect. So, you as legislatures and involved in policy know this. There are no magic bullets. What we know, and what I hope that I've explained to you, is that positive relationships, quality of learning experiences that can be promoted both in home and through a wide range of evidence-based parent education, family support, early care, education, and intervention services are important. And a balanced approach to emotional, social, cognitive, and language development will best prepare children for success in school and later in the workplace. The effectiveness factors for early child care programs for children from birth to age 5. And by the way, I mentioned birth to age 5 because we have done a good job of emphasizing the importance of pre-K, but it's now time to be emphasizing the period of time from birth to 5. because without the foundation that occurs from birth to 5, entry into pre-K, it's already, in some sense, you're behind, and there's a lot of catch-up that would have to occur. So what do you need? You need qualified and well-compensated personnel. You need small group sizes and high adult-child ratios. You need language-rich environments. You need developmentally appropriate curricula and safe physical settings and warm and responsive adult-child interactions. The science points to a two-tiered approach to resolving these disparities. Basic health services, good quality early care and education, and targeted services for children who are experiencing tolerable or toxic stress in order to reduce and buffer the effects of that stress on their learning and behavior. Okay, so my takeaways. Significant brain development already occurs in the first years of life. Healthy brain and behavioral development require positive, sensitive, and responsive caregiving. Toxic stress can derail healthy brain and behavioral development. And finally, providing support to families, good compensation to early childhood teachers, and good quality and basic health care services can go a long way towards enhancing positive outcomes for our children who are the next generation and who we all, regardless of our backgrounds and partnerships, who we all care about. So thank you very much.